All right, this is the last of the videos here. We're going to do an inverted slider crank. Misspelled that right there. Inverted slider crank. It looks like this right here, where we turn this crank and this piece comes back in and out, and then this piece will rock back and forth. There's going to be a fixed angle in between these two. It's showing it looks like it's 90 degrees, but it doesn't always have to be 90 degrees. I've selected problem A as the example, since there isn't one actually in the book. So if I could just find this back here. Okay, so I'm using this data right here. And so going back on our notes, here are the equations that we're going to use to set this up. I'll post them there. Okay, it fits pretty well. So we start with P, Q, R, S, T, and U for this. So P is going to be A times, oh, before I start there, let me turn these into radians. Kind of got out of the way. There we go. So that turns into radians, and that turns into radians. All right, back up to P is equal to A times the sine of theta 2 times the sine of gamma. And we add in the quantity of A times the cosine of theta 2 minus D, right there, that's the ground link. Close the thing here, close the parentheses, times the cosine of the gamma. Looking at it closely, I think I got everything I needed. It ends up being 1. Let me check it. Yeah, for this problem, it's 1. The Q, relatively similar here. Can I? Looking at this, yeah, I'm going to steal some of this. I think I can make this a little easier here. All right, so there's going to be negative is the first thing, difference. So this one is going to be cosine here instead, plus A times the cosine minus D. Here's going to be sine instead. So negative 4.26. Okay, that does match. For R, we're going to be equal to negative C times the sine of gamma. All right, and then S is going to be R minus Q. T is going to be equal to 2 times P. And then U is going to be equal to Q plus R. Boom. Let me double check all those numbers right there. They look to be the same. I'll just paste them over here, double check. Underneath there. Paste the values. And yep, they check out. Then we go to 4. Right here, we're able to get the angle of 4, and so we hit equals 2 times the tangent, arctangent of the quantity negative t. I'll go plus to start with, square root of t squared minus 4 times s times u close the square root, close the numerator, divided by 2 times s, close that, and I think I'm going to close that, and I got the tan down. And let me turn these into degrees. And let's see, did we get the right? 142.67, 142.67, great. And let's use this right here to find this. And the only difference is a negative. Boom. Now, I don't think I have the equations here to get theta 3. So, how am I going to proceed there? I don't think I have them written down, do I? Theta 3. Interesting. Well, I figured it out somehow. Maybe I ought to leave it for you to figure it out. And my notes have slowed my computer down too much to get through. Alright, so let's see here. Theta 3. Let's take a look and see what I did. Okay. All I did was to add them together. Interesting. I just added. Well, that makes sense. Yeah, just look at that. Okay, yeah. You just have to add theta 4 and gamma together, and that gives you theta 3. I don't know what the usefulness of that is, but I'll do it anyway. Equals that plus that. Boom. And equals that plus that. Okay, and I want to look at B too. Let me take a look at B. B is, I'm just calculating how long B is going to be, because B varies actually. So this length right here, which is not labeled as B, it's interesting. I guess we could call it, it's really going to be L, I'm trying to see what we would call this thing right here. Yeah, we call it L3 would be, yeah, this distance. So the distance between A and B is going to be L3. So that would be an important thing to know. So how do we find that? I'm about to sneeze. We could probably edit it out. One more time. Thank you. Okay. So, I see what I could do. In the y components down here, okay, so if we go all the way back up here, if we take a look at the y components as part of this, we could find what b is going to be. Yep. So let me move this back over to here. All right, jumping around a lot. So, all right, something's messed up here. Oh, I see. Okay, because I was still inside there. That gets upset when you're in the middle of something. Okay. So B is going to be equal to the quantity A times the sine of theta 2 minus C times the sine of theta 4. So we'll start out with this guy, divided by the sine of theta 3. Is that true? I think I'm missing a parentheses right here. Boom. 1.789. Yep, okay. And it looks to me like what I just saw is they actually end up equaling each other right here. So let me put this back in here. And the only things that are going to be different is that and that. And oh, one's going to be negative number. Interesting. So I don't get a negative number there. So I'm a little concerned about my negative number. Let me go back and everything over here, I get negative. Let me look over here. That's negative. Boom, boom, boom. Minus. So why are you negative? Maybe it's this guy up here. Maybe I need to worry about him. Oh, that was an issue. Okay, so I didn't get a chance to tell you. Is that gonna? Oh, negative, negative. I have negative here and negative here. For some reason I get a positive there. All right, what did I do down here? That's different. Interesting. And this B is this is sort of an important thing. It should not be negative. And I'm not seeing where that's possible. And where it's different. Oh, I go abs. Okay, absolute value of it. Yep. So it should not be negative, that's for sure. So ABS of this thing. I mean, it just doesn't make any physical sense that it would be negative. But let's take a look at what this thing is. This is probably not one that is easy to picture. So I will make those in here. And so we got A, and that's pretty easy right here. Just go that times the cosine of that. Yep. And this is going to be that A times the sine of this. And that should be the same whether it's the crossed or the uncrossed condition. So we'll put those in there. And then 4, that's just going to be, let's see, D, right, in the x direction. And D in the x direction. And both of these are going to be 0 because it's always going to be 0. So if we want to go up to B, easiest way to do that is to go, okay, so I'll go equals to, I'll go backwards this way, yeah, that plus, is this going to be true? I think so, yep. That plus C times the cosine of this angle. I think that's going to get us where we want to go. And then also that, which is 0, duh, but plus that C times the sine of this angle. And similarly that plus C times the cosine, but now of this angle, I probably could have just copied those over here. So I could have just gone like this right here, right? Copy, put it over here, and then just change the angle. Boom. Let's see what happens here. I will insert my graph right here, and let me move my cheater thing over. Boom. Okay, so that's what it looks like. Interesting. I had to get rid of him. And I'll move these guys up here. Let me take a look at what my increments are. Format this axis. We go 0.5s. And we still need to be a little shorter. Yeah. And one of the things we could check as part of this when we're looking at this is that these two should form 90 degrees from each other, because that's what we have for this gamma. As you look right here, you could see this configuration. You could see in the orange the alternate configuration that this could be. So there you go. That's what we've done here is made a tool that now we can plot or we can figure out what the configuration of an inverted slider crank is going to be. And we could print this out by setting the print right there, set the print. Back over to here. See that it's not going to fit on one page, but let's see, we go to page setup, make it landscape, fit onto one page, horizontal, vertical, and boom. There you go. We did our homework. So that's the video. And it took me 16 minutes.